Hello everyone, welcome to the second lesson of our first unit. This lesson is called function notation, and it's an important skill moving forward in this course and then into grade 12. So what is function notation? It is notation such as f to x used to represent the value of the dependent variable, or as we know, y. Okay, so normally we see an equation as y equals mx plus b. We're replacing the y with fx, so it's f to x. And why are we doing this? Well, y equals mx plus b is a linear line and it gives you the entire line. But with function notation, we're able to find a solution for one specific point. So for example, in the function fx equals 3x squared minus 4x plus 1, we're going to solve for these specific x values in this quadratic equation. So the first one, it says f and now a 2 in the bracket. So the 2 replaced the x from the original function. So that means we're going to replace each of the x's in the function with the number 2. Okay, so it's telling us what specific x value to use. We're going to work this out. So we use some BEDMAS. And we get 12 minus 8 plus 1, which is 5. So in this equation, when we have an x value of 2, the solution will be 5. Okay, what about when x is negative 1? Okay, it's no different here. We're still solving the exact same way, but this time we get an answer of 8. Okay, when x is 0, well, if we remember quadratics from last year, we know that 0, or the y-intercept, is just the c value of the equation, or the only number that does not have the variable with it. So your answer will be 1, but let's plug it in just to make sure. Okay, so we get 3 times 0 minus 0 plus 1. So 0 minus 0 plus 1 equals 1. Good. And finally, just to confuse everyone, what if there is a number and a variable in to replace our x value? Well, what this is going to do is give us another function. So negative 2a squared is 4a squared plus 8a plus 1. I don't know why I drew a bracket there. Wait a second. And we get 12a squared plus 8a plus 1. For right now, we're just going to leave this here. If you really wanted to, you could factor this out and figure out that a could be a sixth or a half, but we're not going to do that. We're just practicing function notations. We're plugging negative 2a into all the x's, and we get another quadratic function. Okay, consider the function fx equals x squared minus 3x, and gx equals 1 minus 2x. So these are two different functions. So we have an f function and a g function. Show that when the x value of the f function is 2, we'll get a smaller answer than when x is 2 in the g function, and explain what that means about their graphs. Okay, so the first one, our f, we're plugging 2 into the x's, so we get 2 squared minus 3 times 2, so 4 minus 6, which is negative 2. Then we work the g function. We have 1 minus 2 times 2, 1 minus 4, which is negative 3. sorry, it's supposed to be greater than, which it is. Okay, so we just solved both equations and found out that when x is 2 in the f function, it has a greater value than when x is 2 in the g function. So if you were to graph both of these, you would find when x equals 2, the f function has a greater value than the g function. Good. Determine g to 3b. So this tells you which function to use, and this tells you what you're plugging into your x. Okay, so we have g, we're replacing the x with 3b, and it's 1 minus 2 times 3b. So we just simply get 1 minus 6b. And that's as far as we can go. Those are not like terms, you cannot collect them. Okay, determine f to c plus 2 minus g to c plus 2. Okay, so like in BEDMAS, you're going to do the addition or subtraction last. You're seeing these as brackets, these functions. So that minus sign in the middle, we're going to do this last. So what that means is we're going to solve the f function, then we're going to solve the g function, and we'll subtract the answers. Okay, so we have f at c plus 2. And our f function was c plus 2 squared minus 3 times c plus 2. So c plus 2 is a binomial. When you square that, it's really FOIL, if you remember that from quadratics. So we're going to get c squared plus 4c plus 4 minus 3c minus 6. We collect our like terms. We get c squared plus c minus 2. Now we work with the g function. One minus 2 times c plus 2. 1 negative 2c minus 4, and we get negative 2c minus 3. Okay, we just solved the f, then we solved the g, and now it wants us to subtract them. So we have c squared plus c minus 2, and we're going to be taking away negative 2c minus 3. So we have 1c minus negative 2c, which gives us 3c, and we have negative 2 minus negative 3, which gives us positive 1. So there is our final answer. Okay, and then on a graph, it's actually really easy. For the function shown in the graph, determine each value. So this blue line represents the g function. It wants to know what is the value, what is the solution when x is 3. So for that, you just go to 3, go up, and you see that the solution is 2. What about when it's negative 1? Well, there's when x is negative 1, and the solution there is 0. This time it wants to know the x value if gx equals 1. When you have something like this, it's telling you the solution. The solution is 1, and it wants to know what x is. So we're going to look for when the function reaches 1 as a y value, and we see that x will equal 0. Okay, and then the domain and range, as we've spoken about a little bit. The domain Because this can include all real numbers, we're going to start with XER. Now you can see that this has a restriction. It doesn't go further left than -1. So all x's are greater than or equal to -1. The range in this equation also has a restriction, and it's always greater than 0. So y is greater than or equal to 0, and that's our domain and range. Okay, so that is function notation. Have a great day.